Meet you.
Hi, you can. Nice to meet you too.
I may introduce myself a bit, and everybody know you. And I'm a professor at Imperial College.
Mm-hmm.
I've been there for 33 years. I run a data science institute, but now I moved to Hong Kong for 3 years. I take the vice president job in Hong Kong Baptist University. My area is, I was started in Imperial on the computational logic. I'm kind of an old-fashioned AI guy. So,
Okay.
but now I'm reading your books. I find it absolutely exciting because it's quite very much related to what we learned before. Not really too much, actually, current fashion. So
Right.
I met Peter 2 years ago, and I know you have a book project. You are right on the fourth edition of the wonderful book.
Oh,
So
that's
how's
already
it going?
That's already
Finished?
Yep.
Wow, excellent. We're actually looking forward to that. But I'm thinking about the book you wrote before, this textbook, and the book you're writing now, or you already published this human compatible. I think the fourth edition will be quite hard to write. It'll be totally different, right? Because you changed the entire definition of AI.
Yeah, I mean, that's a real problem because basically in the first two chapters we say, okay,
Yeah.
everything we told you last time was wrong, and here's how to think about AI instead. But unfortunately, we don't have all the new material for the other chapters. So most of the other chapters are still in the old model, the standard model. There's a few places, I think, in we cover inverse reinforcement learning. In the decision theory chapter, we talk about what happens when you're uncertain about the objective. We talk about the off-switch problem, and so on. But we have another decade of research we have to do in order to really have the fifth edition be the way it should be.
So there will be fifth edition, sixth edition, more and more approach to your new definition, I guess.
Yes, particularly if I can take a pill to remain young forever. Yeah.
It will be. Yeah. Well, I read the books. I really find, really you're human compatible. I think that will be the very important piece of the work in the AI. So while reading it, I feel, right, you think about AI is like building a tourist human from the newborn baby, right? And by observing other people's behaviors. But my question here, and I always reading that, I think, being altruistic is such a hard thing for human being self. But how can you actually guarantee, how can you actually make sure the machine is actually be altruistic, not to think about its own values? Are you allowing machine to have value?
So as I was saying, I think you're right that machines in general will start out like newborn babies. Any particular machine, so when you buy a robot, to keep the house clean, it's not going to come as a blank slate, right? It's going to know lots and lots about the preferences of human beings in general, and even the preferences of human beings, who live in your area, who come from the same socioeconomic background as you do. So it'll be a reasonable robot right out of the box, but it'll still need to adapt to your particular, maybe you're a vegetarian and it doesn't know that, so it has to learn your preferences about what you want to eat, what kinds of things you want to keep in the fridge, and so on. So how do we prevent the robot from developing its own values? We don't give it algorithms that could possibly do that, right? When we set up an assistance game, the algorithm we put in the robot is an algorithm that solves the assistance game. And the solution to the assistance game is essentially an algorithm that learns more about the preferences of humans and then tries to satisfy them. And there's no place in the algorithm for any preferences of the robot at all. And it has no difficulty being altruistic because that's how it's defined. Right? I could write a chess program that always loses whenever it plays me, right? And it's not hard to do, right? And I could just do that.
Yeah.
I give it a reward every time it loses, and it learns to lose really fast, and that will be that. So I can make AI systems that are altruistic. I think the real difficulty is that human preferences are themselves really, really complicated.
Yeah.
They are not stable, meaning that they are malleable. We can, our preferences can be molded by outside experience. And they're expressed in a way that's not always easy to interpret, because we have our underlying preferences and then we have our behavior, and they don't always line up, right? I mean, one example is just the computational limitations. So when a chess player or a Go player loses a game of Go, it's because they made a losing move. But that doesn't mean they wanted to lose.
Yeah.
Right? If you thought they were rational, you'd have to assume that they wanted to lose because they made a losing move. But that's not the case, right? They made a losing move because of their computational limitations. And similarly, when we do something emotional, we regret it. Usually, right? We lose our temper, or we're afraid, or whatever it might be, and we act in a way that we later regret. So all these deviations from perfect rationality have to be taken into account when the machine is trying to interpret what it is that we really want the future to be like.
Yeah.
And those are complicated questions, and I imagine that it may take decades to really solve them.
Right. So when you're talking about, reasoning human preference from the behaviors, so that's really you want a machine have certain kind of the ability to thinking about the causality, right? Or even try to understand. Yeah. So you needed to understand, this is the behaviors is the result of certain kind of intention. But that's a pretty hard work. How can the machine verify, to actually these causality relationships?
So it's kind of like doing physics, right? When we observe the consequences of physical laws, and we do physics to figure out what the laws are that produce the behavior. And so there's already a discipline of inverse reinforcement learning, which does exactly this. And you're essentially trying to find simple reward functions that do a good job of explaining all the behavior that you see, on the assumption that the reward function is translated into behavior roughly in a rational way. So for problems where humans are competent, where we can behave rationally, competently, it's already starting to work. We're able to learn some quite sophisticated preference models. But in areas where human behavior is really very much constrained by computational limitations, which is a lot of what happens in the real world, right? Our behavior is nothing like rational, right?
Yeah.
If it was rational, right? So think about it, right? We get to control our muscles at about a 1 millisecond time scale.
Yeah.
Okay, and we live for about 100 years. Okay, and we have 600 muscles, so it amounts to, I think, 20 trillion actions that we get to do in a lifetime. Now, if we were being rational, we would choose the first one of those 20 trillion perfectly, right? With a max over all the other 19 trillion 999 million billion steps, right? It's completely and utterly implausible that that's what we're doing, right? What do we do instead? Well, we mostly organize our behavior in hierarchies, right? So what am I doing right now? I'm talking to you about the book and about the talk, right? So that's an activity. And I made a choice to do that, right? So now I've committed a whole half an hour, right? Which is probably tens of millions of motor control actions, right? And then once I've chosen that, that enormously limits the kinds of things I could do, right? Theoretically, I could take my cell phone out and start trading stocks, right? But because I've agreed to talk to you, I don't do that, right? There's only really one thing I can do, which is to talk.
You spend a lot of money.
Yeah. So when you look at yourself and what you're doing right now in your daily life, it's all like that, right?
Yeah.
We are nested in this very deep hierarchy of commitments and goals and sub-goals, none of which make sense from the point of view of a perfectly rational
Yeah.
AI system that solves the decision problem perfectly. Right?
Yeah.
There's no reason to have structure. There's no reason to commit to sub-goals or any of that stuff. But we do it because it makes life computationally feasible.
Right. Great. So, I mean, even this one is computationally feasible, but I think that when talking about human behaviors, right, our behaviors are also not just structured, but also quite interactive, right? I change my behaviors because I've observed the environment to change. I want to fit some kind of the purpose, and I do have some prediction of something, but I find that the environment is disagree with me, and I change either environment or myself. So there is a quite interactive, right? But when you use machine to do that, you observe a human or make group of human, there is a lot of different behaviors there, right? It's conflict everywhere. But how can he actually reasoning about, right, what the behaviors he want to acquire to understand the common preference, for example? And also, carefully, and this machine actually you actually program it to become altruistic. So it's not going to think about himself at all. It's think about all you guys. That judgment is really, amazingly, I want to say the computation intensive. I think it's really hard to think about it, even from a physics point of view.
Yeah, I mean, it's fortunately, right, the problem of inferring human preferences from behavior is easier than the problem of general intelligence. Right?
Yeah.
So hopefully we'll make significant progress on that problem before we have to worry about controlling, general intelligence systems that are superhuman. And I think, we have to help, right? I think the idea that we're just going to, have a giant neural net with, 1 trillion connections and it's just going to watch humans and learn, I think that's nonsense.
Absolutely.
There's an enormous amount we know about our own behavior and our own preferences.
Absolutely.
That we can encode up front, and we'll get lots of experience in lots of narrow application areas. A travel assistant, a diary assistant, something that helps keep the house clean, right? Each of these systems doesn't need to understand the whole thing. As we gain experience, we'll understand much better how to do this.
Yeah, great. Thank you. So when you're talking about this, your whole idea about the provable beneficial AI, so when you talk about this provable, right, who's going to prove it? Human? Machine? How actually prove it?
Well, so the first theorems that we've proved, we prove them as humans. And they're theorems about an abstract system, right? A single human who's rational, a single machine that's observing the human, in a fully observable environment, So the typical restrictive assumptions that we make in order to design algorithms that have provable properties. So as we, just as we do an ordinary AI, we relax those assumptions, we develop more sophisticated algorithms, and we update the proof to accommodate this larger setting. Now, when we talk about theorems about real humans, I think you have to make, of course, for any theorem, you have to make some assumptions. But the assumption in sort of version 0 of the theory is that humans have preferences that remain constant. Right? That if I prefer that tomorrow be sunny, then unless I have a good reason, I don't wake up in the morning and say I wish it was raining, right? So this notion that of what we call stationary preferences is a really important thing. It doesn't mean that your preferences can't change, but
in a fixed amount of time, right? Yeah.
Right. If they change, they have to change because you got new information
Yes.
about your own reward system. So you can learn that you don't like a certain food, and then your preference changes. Right now, I say no, I don't like that, so I'm not going to eat it. That will be updating of preferences, but just preferences that change for whatever reason, right? Maturation or drugs, alcohol, aging, whatever it might be, right? Propaganda. That's harder to deal with. So right now, I think if we assume stationary preferences, then the kinds of theorems we need to prove are basically number one, does the learning algorithm get closer to, first of all, understanding your preferences, and second of all, understanding your cognitive architecture, right? The mapping from preferences to behavior.
Yeah.
As long as those things happen, then you can start to prove theorems, about typical approximation theorems, that things will converge, the error won't be too large. If there's some really big error, you're going to catch it fairly soon, and so on. The other important point is that when you have uncertainty about preferences, the fundamental nature of how the AI system behaves changes. Right? It automatically starts to be cautious. It's what we call minimally invasive. So it doesn't change parts of the world that it's not sure which direction you want those to be changed.
Right.
So it leaves them alone because that turns out to be
that's a key point, right? Uncertainty.
Yeah. Right. Yeah. So the uncertainty, and then it defers to humans. So if humans say stop or I don't like that, then that's new information.
Right.
Which causes, and then the system listens to it because that's what it has to do.
Yeah. I feel the wonderful thing is enabling the communication between the machine and the human happens, right? That was the beautiful part of the theory. So it's a kind of the foundation for the future, this symbiotic society, right? Machine and human work together.
Yeah, I think that's sometimes I give a talk called AI, a binary approach, right? So
yeah, right.
But you really have to look at this coupled system of human and machine, rather than the machine by itself, which could go off and do anything.
Absolutely. But if you're talking about binary AI, so you have the human compatible machine, but surely you also want a human to be a machine compatible human, right? Somehow.
So I don't want to be in the position of an AI researcher telling humans what they should be like.
At least you can express your preference in a probably better way or somehow.
It's not very popular. I don't have a democratic mandate to do that. But one problem that we have with humans actually is so it's something that early economic theorists such as John Hassani called sadism. Right. Sadism means that you have preferences, you have negative preferences about the well-being of other people.
Yeah.
So you literally derive happiness from someone else being unhappy.
Yeah.
And in the theory of utilitarianism, right, which basically says you should try to maximize the sum of everybody's happiness, then if you have a sadist, right, perhaps you can make the sadist happy by hurting somebody else, and that doesn't sound right.
Yeah.
Okay. Yeah. And philosophers have written books and books and books about this. And Hassani's response, which is the same as mine, is basically you just zero out those preferences, right? If people have negative preferences about the well-being of others, you just replace them by zero. And I think that's perfectly reasonable.
Yes.
The second problem that humans have is that our preferences are often relative, meaning I'm happy because I have a shiny car, a nice big new shiny car, but I'm really happy because it's bigger, shiny, and newer than yours, right? So these relative preferences turn out to work exactly the same way as sadism, because they end up attaching a negative term to your well-being, right? So that my relative well-being can be higher if yours is lower, right? Now, if you try to zero out all these relative preferences, that's really a much bigger deal. I don't think there are very many sadists, real sadists, but I think almost everybody has relative preferences as a big part of their, who they are, right? I mean, even something like a Nobel Prize, right? Why is a Nobel Prize so great? Well, they give you €1 million, all right? No, it's because a Nobel Prize tells you that you are smarter than everybody else in the world.
Absolutely.
Right? If everybody in the world got a Nobel Prize, you wouldn't want it, right? So this relative well-being is really important to people, but it's problematic from the point of view of how does a machine try to optimize on behalf of everybody.
Yes. But it's quite hard, right? It may end up with you confused completely with preference, because everybody's preference, as you said, is kind of relative, right? So it's not trying to be completely rational. So that is probably a very big research area. And what's the corrective preference? But if you really get all these things learned, maybe what you learn is common sense. Is that right? Or
I think it's a big part of common sense, but I think what's interesting, when children are learning, I don't think we humans really distinguish between these different kinds of knowledge, right? So learning about what people typically like and don't like, and learning what happens when you drop a glass on the floor, they feel pretty similar as learning tasks. And I think it's very natural for humans actually not just to learn what other people's preferences are, but somehow I think we then kind of adopt them. I think this is actually a major process by which our adult preferences are formed, is actually a kind of internalization of other people's preferences. So we're not just learning that, oh, my mom likes this and my dad like that. We're actually learning that that's what we want ourselves.
Yes.
And
yes.
That's a different way of thinking. I think most people in AI have always thought that if humans have preferences, they're just derived from biology, right? Our hunger, pain, etc. Our biological reward system. But actually, on this view, it's much more social, right? That our preferences are absorbed from our culture, and not just our biology.
But the kids and the human can learn so well about this because they are not really altruistic, right? They have an internal sort of the drive. I will do something good for myself. That is quite a big drive. But this time, this drive is gone, right? You have to really, only fit other people. And other people is not just one person; it's all of them. So that is pretty hard than human, right? So you basically build something which is more sophisticated than human kids, right? That was the learning process will be quite different, I guess.
Yes, but it's also the case that machines have this very important advantage, which is that they can share their data very easily.
Yeah, right? I think big thing,
So everything they're observing, subject to the usual privacy rules and so on, can be shared. And when we build a complicated hierarchical Bayesian prior distribution about preferences, and then use that so that we can quickly adapt to other people.
So it's really follow the Bayesian principle, right? You really start with the hidden variable, the preference, observation, and the behavior, and you just infer it. It's largely from that angle, right?
Yeah, I think that's a good way to think about it. The complications come because of the multi-agent nature of the problem. Right? So the data that are generated are not purely statistical, right? They're actually generated by another intelligent agent who's participating in the same game. So you can't just do Bayesian updating. You actually have to solve the game in order to understand what the human is trying to tell you.
Game theoretical, right? Because the population is not stationary. That's it. Okay, got it. But come back to this symbiotic society. Now you have a great machine, which is really great, altruistic and help you and do the job for us. But also, the society changed because you have two things work together, right? I'm sure it is because societal structure will have some change, right? Because you do have something done by machine and acting as an active member of the society. So what you envisage in this symbiotic world, right? Our social structure, our legal systems, and even our governing, right? The culture. How does change can happen because of you have another,
Well, yeah, those are all good questions, and if I knew the answer, I'd be writing the scripts to lots of science fiction
that's
movies.
what the seventh edition of a book.
So, I mean, I think one important question is, if we have general purpose AI available to us. So the benefits are enormous because with general purpose AI, and physical realizations in the form of robots and aircraft and trucks and so on that can do all the physical work, that basically constitutes an unlimited source of wealth.
Yeah.
For everybody, right? Right now, things that involve people are really expensive, right? I mean, so what Google does for us, or Baidu, or any other search engine, right? That used to cost, you used to have to hire a consultant to do research in libraries for hours and hours and hours and hours. It might cost you $1,000 for a typical query, right? And Google gives it to us for free, and there's, I don't know, whatever, tens of billions of these things every day. And so things that have human involvement are expensive just by definition. And particularly in developing countries, they not only can they not afford that, but they don't even have access to enough trained human beings, engineers, surveyors, construction designers, et cetera, et cetera. So they cannot produce a good standard of living. With AI, because there's no humans in the loop, there's no humans anywhere in the supply chain, all the way from the raw materials to the finished product, whether it's a hospital or a railway or a new airport, we can just do it. And so it completely changes the dynamics of our economy.
Yeah.
And in fact, what will remain expensive is human time, because that's in short supply, and since each human will be sort of unlimitedly wealthy, they won't give their time easily.
Yeah.
So it'll be a very different world. I still think land will be expensive because the AI systems, at least for now, can't make new planets. So land is going to be expensive. But the other question then is, okay, so if AI can take care of our whole civilization for us, right? If the AI systems do all the engineering, all the design, all the science, all the medicine, why would we even bother going to school? Right? Who is going to do 20 years of education to become, a surgeon or a computer scientist when there's no jobs for surgeons and computer scientists, right? When AI can already do that.
Yeah.
And so that to me, and there's been a lot of predictions going back even to, so Ian Forster wrote a story in 1909 called The Machine Stops. And he talks about a civilization where the machine does everything for human beings. And as a result, we become enfeebled. We forget how the machine works. And then, when the machine breaks down, we're in real trouble. And same thing if you've seen Wall-E, right? All the humans on this giant spaceship, they just become, overweight, stupid. They no longer know how the ship works. They don't know how anything. They don't know how to do anything. So this is a warning, and it's been a warning even since ancient Greek time.
Yeah, I understand. Yeah, carry on. You was talking about the human doing nothing and the machine did everything. Yeah.
Right. So if that's a concern, and obviously, at least to me, it's a concern. I think it's a concern to everybody.
Yeah.
Right. Then presumably the machines will understand that that's a concern, right? And basically, what it means is that autonomy and capability, knowledge, skill, these are all things that we want. These are part of our preferences.
Yeah.
And so that means the machines have to not do everything for us.
So, yeah.
Right? They have to, in some sense, they have to refuse to help us tie our shoelaces. And we have to learn to tie our own shoelaces. So this is a strange relationship, right? Because in some sense, that sounds like, parents and children, where the AI system is our parent and we are the child, right? But at the same time, we are supposed to be in control of the machines.
Yeah.
So we don't have a good model for this kind of relationship.
Yeah, that's why I'm saying, this machine compatible human may be also quite interesting because it's really kids and the parents, right? And we are the parents, but parents learn also from kids. And try to be a good parent is sometimes a very big drive to be a good people, right? So I think the very good drive of our sort of improvement is try to be nice because of the kids educate you. So that's could be.
And I think, because as you say, our machines are designed to be altruistic.
Yeah.
So they will actually be role models for us, right?
Exactly right. Exactly.
We may see that actually the machines act as a kind of a mediation system that actually smooths out relationships among people. And we will learn as a result, okay, we don't need to be so greedy. We don't need to be so aggressive, so competitive.
That's probably
and things turn out better if we don't.
Yeah, think about the two persons have a quarrel and have a fight, and the machine sit in the middle, right? He understands the conflict of preference. What do you want to do? He wants to make you two compromise. Yep. So machine human may be compatible with such kind of a wonderful altruistic human. Very interesting. Thank you. Very good. I think my final question is, it's a wonderful journey we'll start. I can see, right? I totally agree. With the deterministic objective, using machine to optimize it is not the way we go. But it certainly cannot go too far. I can understand that. But what is the really starting point, right? What is the start point of journey? Well, how we can really, deep learning made a very big advance because of the image, right? So they must have some starting point. So what is the starting point we can do now as a breaking sort of the field for us to advance? So therefore, this wonderful beneficial AI can actually have a sort of application and have a starting.
So I think that's a great question, and I've been discussing this with my colleagues and students, and we see several directions. So in personal robotics, I think is a very good application, and even the self-driving car, where in fact figuring out the correct objective for a self-driving car turns out to be really pretty difficult. And you try, some combination of speed and safety and, legality and so on, and it never quite works. And of course, you want the car to adapt to individuals. So that's one, personal robots, self-driving cars in the physical area. And then I think just the personal digital assistant would be a really good application area. So something that helps you manage your life. It's like when you're a CEO, you have a really highly paid executive assistant who runs your calendar, books your travel, makes sure that your kids get to school when you forget, et cetera, right? So, so that kind of personal assistant, I think, could be available to everybody. And it's clear that how you behave when you're working for, a computer science professor is very different from the way you behave when you're working for, a president or a bus driver. You have to adapt to the individual and their family, their relationships, their preferences. So the reason why those systems haven't taken off so far is partly to do with the difficulty of understanding language. So for them to be effective, they really need to be able to read emails, listen to telephone calls,
reading.
Use that to build up a picture of your life and what you care about. But I think that in the coming decade, we are going to see a lot of progress on language. Maybe from deep learning, maybe from probabilistic programming systems, which is what I'm betting on. And so I think these two things coming together, the ability to learn about preferences and the ability to use language to gain knowledge, I think means that this might be the right application area.
So in this sense, right, the deep learning, all this stuff can be sort of the pre-processing engine for this, I guess, probably, right? So they still have their function, right? And
yes, I mean, we don't learn preferences based on video.
Yes.
Right. In other words, we don't think of preferences as a mapping from video to a real number, right?
Yeah.
We think of it in terms of abstract features of our lives, like, am I healthy? Do I have a secure job? Are my children doing well at school, right? And that's not a video, right? These are abstract facts about my life. So there's plenty of room for perception. In fact, perception in general is a fairly harmless thing.
Absolutely.
Right? So the better perception becomes, generally, I would say, the better the outcomes are for us.
Right.
It's the decision-making side where things go wrong.
Right. So the perception can still use the deep learning things, and then decision-making, we can go for this provable beneficial AI.
I mean, they're not right. Then they're not in conflict, right? You can have
you can join together, right?
So even deep learning, right? Even deep learning for images, uses an objective.
Yes.
And I think this is important to understand. And typically, what they use is minimize the number of errors on the training set.
Yeah.
And they count all errors equally.
Yeah.
And unfortunately, if you classify a person as a gorilla, which Google Photo did, that error is incredibly expensive, right? That error probably cost them billions of dollars for that one mistake.
Right.
So they used the wrong objective when they were training their system. And a lot of these examples with bias can be interpreted as you're training a system with the wrong objective, right?
So thank you. Maybe the starting point is let's see, how to improve the utility functions or object functions in deep learning. Put more and more common sense, more our preference into it, and see how this improves. That is also another way, right? I think.
And have learning systems that are uncertain about the objective.
Yeah,
right?
absolutely.
Sometimes they say, I'm not sure that I should classify this image because it might be a big mistake. So what I'm going to do is go back to the boss and ask a question, right?
Get more information.
So I have students who are working on, how do you design learning algorithms that have uncertainty about the statistical objective, right? The loss function or the loss matrix.
Yeah.
And you can do recommender systems is another application area that we're looking at, because I think, all of the content recommendation systems in social media, YouTube and Facebook and all these, they are optimizing some fixed objective.
Yeah.
And as a result, they've made a mess of the world.
Yeah.
Okay. And we should really be doing things very differently.
Okay. Thank you very much, Stuart. It's a really great honor to talk to you.
It's a pleasure, Yike. Thank you for your questions.
hope that all the pandemic finished. You can come to Imperial College again to see your CDC.
I would love to do that. Yep. If it's still there.
Yeah,
right.
I think it's gone, but we can find the Science Museum. Goodbye. Thank you very much. Take care.